Okay, this is problem 18, I believe. Okay. Industrial ethanol is produced by the catalytic reaction of ethylene with water at high pressure and temperatures. Calculate the delta H of reaction for this gas phase hydration of ethylene to ethanol. So from this to this. Using bond energies and then enthalpies of formation. This should be fairly easy and this should be somewhat hard. So we're going from CH2, so CH's double bond CH with water, and that gives us industrial ethanol, so CH, that gives us the CH3, and then we got CH2, and then we got oxygen and hydrogen. So now we gotta know how many bonds we have, or like which types of bonds we have in each substance. So here we have 1 CC and we have 4 CHs. So 4 CHs and 1 CC. Here we have 2 OHs. And then here we have 5 CHs. We got 1 CC, 1 CO, and 1 OH. Yeah, because so 1, 2, 3, 4, 5, 6, 7, 8, and this we have 8 in total. Okay, so we didn't miss anything. Let me erase this. Okay, now we're gonna do energies of the old bonds breaking plus the energies of the new bonds that are forming. So these are the bonds that are forming and these are the bonds that are breaking. So to start off, we got 4 times the CHs, which is 413, based on the table 9.2 in your textbook, plus 1 times CC, double bond, which is 614, plus 2 OHs, which is 467. And then you add that to 5 CHs, and CH is negative 413. I'm saying negative because for the bonds that are forming, they release energy, so they are considered exothermic. So we got 4 CHs, we add that to 1 of the CCs, which is negative 347. Add that to 1 of the COs, which is negative 358. Add that to 1 of the OHs, which is negative 467. And then you'll do the calculations. 467, this to that, plus 614. And I got negative 37 kilojoules. So that's the answer for using bond energies. Now to calculate it for the using heats of formation, so we're going to do delta H of the products minus the delta H of the reactants of the same formula that we had beforehand. So the delta H of CH3 CH2OH minus delta H of CH2 CH2 added to the water, which is H2O. So, and these values you can find in your appendix B, or you could look them up. So negative 2, that's not 2, 235.1 kilojoules. For the ethanol, subtracted from 52.47 kilojoules plus negative 241.826 for the water kilojoules. Adding all these together, or you subtract. And I got negative 45.744 kilojoules. So that's the answer for using the heats of formation. Now it's saying ethylene glycol is produced by the catalytic reaction of ethylene to ethylene oxide, okay, which then reacts with water to form ethylene glycol. Okay, the delta H reaction for this hydrolysis step based on the enthalpies of formation is negative 97 kilojoules per mole. Calculate the delta H reaction for the hydrolysis using bond energies. Okay. So we're going to have to find the amount of bonds that are, we're going to have to find the amount of bonds, specific kinds of bonds in these substances, and then we're going to have to do the same thing that we did over here. So for the ethylene oxide, we have 4 CHs, we have 1 CC, we have 2 COs. So 2, 1, that's 3, 4, 7. So 1, 2, 3, 4, 5, 6, 7. So we did that correctly. And then we have 2 OHs. And then here we have 4 CHs. We have 1 CC. We have 2 OHs. We have 2 COs. That's in total 4, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we did that correctly as well. And now we do the same thing that we did in the first part. So 4 times CH, which is 413, plus 1 CC, which is 347, add that to 2 CO, which is 358, and then add that to 2 OHs, which is 467, and then we're gonna add that to the bonds that we're forming, which are going to be negative because it takes energy to form bonds. So one of the CCs, which is negative 347, plus 2 of the OHs, which is negative 467, plus 2 of the COs, which is negative 358. Add that to 4 of the CHs. CHs are negative 413. And now you add them together. $3649 minus 3649, which is 0. So both of these sides are 3649. So the answer is 0 kilojoules.